Before we get to today's experiential exercise, I want to remind you of the function of the left brain. And we didn't find this out by introspection. We found it out through experimentation, through split brain patients who literally had the two sides of the brain severed and disconnected through surgery. And they would give commands to the right side of the brain, things like stand up or raise your hand. Now, the left side of the brain, the part of the brain that controls speech, is totally in the dark about this. It should say, I don't know. A very Zen kind of thing to say, but it didn't at all. In fact, when asked, why did you get up? Why did you raise your hand? The left brain spontaneously came up with a plausible, but completely wrong and incorrect answer. But here's the point. When they observed these patients, it wasn't so much that they got the answer wrong. It was the confidence and kind of natural way that they arrived at this conclusion and totally bought into it that was really surprising. And that's why they ended up calling the left brain the interpreter. So far, I've been calling this the mind program, Mind 1.0. Now, for today's example, I want to go through the Monty Hall problem. You may have heard of it before. Maybe you heard the show. Monty Hall was a game show host, similar to myself. And he did a show called Let's Make a Deal. Pretty simple idea. Let's imagine you've got 3 doors, and behind one is a really good prize, a car, something, vacation. Behind the other 2 is a joke, maybe a goat. And of course, you want to pick the good prize. And so let's just say you go with door number 1. Now, this is when Monty starts making a deal with you. And he says, okay, I'm going to show you what's behind door number 3. So he reveals what's behind door number 3, and it's a goat. And here's the deal you have to make. And what I want you to do is just observe what goes on in terms of the thinking mind. Observe the voice in the head, the confidence levels. Just sit back and watch. It will completely take over and come up with an answer. And here's the question. Do you stay where you're at? In other words, is it irrelevant whether you change? The odds are going to be the same. Or do you actually increase your odds of getting the prize if you now switch from door 1 to door 2? Now, chances are, if you're like a lot of smart people out there, you probably heard the thinking mind say something like, well, it's irrelevant. And you may have even been like these split brain patients and had a very confident sense of it doesn't matter. And that's wrong. In fact, some of the smartest people on the planet not only defended that, similar to the split brain patients, but the only thing that convinced them that switching increased the probability was to show them data from computer simulations, which would run this through endless times and then calculate the odds and the data. And you would actually see that by switching, you do increase your odds of winning the good prize. Now, again, when I talk to my students about this, I try to give them a real short explanation, but it really doesn't work. And it's something like, initially, your odds are 1 in 3. Once that new information is revealed, now the odds are 50-50, and that's better than 1 in 3, so it's better to switch. But no amount of reasoning seems to really work, and that's why I like this example, because it shows the mind program, even in us, quote, normals with an intact brain that communicates with each other, the left brain still seems to step up, and it's so confident in its answers, even though, particularly in this case, it's wrong.